Hello everyone. Today I would like to talk about object-oriented design interview question. Shortly we call it OOD. Object-oriented design interview question can normally be used to evaluate the candidate's availability to understand those object-oriented design concept. Those questions, they are not so much about you repeating the definition of the design pattern or some other stuff, but uh, they want you to demonstrate your understanding how to create those elegant and maintainable object-oriented code. And poor performance on this type of the questions might raise a serious red flag on the interviews. Okay, so this time let's see. We would like to talk about a famous commonly asked question. So this is design a parking lot here. There are several pitfalls that we need to be aware when we do those kind of the OD interview question. The first is that um, interviewee, you just start talking on and on and do not have enough communication with the interviewer and try to make a lot of assumption without asking or confirm with the interviewer. So for example, let's say design a parking lot, then you start with, for this parking lot, we might need multiple levels and let's make it able to park bicycles. The interviewer might have their own idea how you want to approach this one. So it is your job to ask questions and clarify what is exactly the type of the product that they want you to build here. Otherwise, you basically go into the wrong direction and whatever while you do, you just solve the wrong problem here. And the next question is that for this kind of the interview, you need to be clear that it's different than the algorithm or the problem solving or another kind of the system design interview. Basically, for this interview, they are more focused on how you design the relationship, what is the core object, and how you make the code maintainable and easy for the change in the future instead of uh, design some fancy algorithm or make the system more scalable for thousands of the nodes. That's another part for this one. And also to tackle this problem, it's better you follow some strategic approach to do them step by step instead of design something in the beginning and then change it in the middle and do it back and forth, which will show that you do not have a logical thinking and also hard for the interviewer to follow up with your mind. And also, when you design something, just like the coding, in the last of the interview, you probably should check the correctness to ensure that you have covered all of the things that the interviewer asks you to do. This is also something we need to check before we call it done. Okay, to solve this kind of a problem, I think we can follow some normal approach here. Let's write down something here. We can first do the clarify. Basically, we need to ask interviewer what is exactly we want to solve here. And then after the clarification, we get some basic idea. Then we need to define some of the core object here. Basically, we want to define what is the major things that we want to deal with and what is the relations with each other. After we have those kind of the core object, we should be able to easily move on to the next step, which is the use cases, or we call it cases here. We want to determine what is the required thing we want to implement for those scenario and those functionality. And then after we have those cases, we should be able to move on to the classes, which will give us the more details about the the class that we want to build to support this use case. We can use the UML class diagram to help us to do this stuff. The last step, as I mentioned earlier, for every of the things we need to do, check the correctness. We need to make sure that we cover all of the things here and we do not miss any important things. So let's look at the one by one. The first is the clarification. So what kind of the parking lot is, and what we are trying to do here. Maybe we can say this time we will ask the interviewer some questions, or we will provide some available options for the interviewer to confirm which one we want to go with. It can be that in a real world, the parking lot we need to deal with the billing system. So basically, we want to charge the customers fees. Depends on how long they park in in our parking lot. So then there are some assumptions that this parking lot is not a free, it's a commercial or the paid parking lot. And also it depends on whether how you charge the customer. Whether you charge the customer at the entrance to pay some money for the certain amount of the time, or you charge the customer at the exit. So basically, this is a area called the parking lot billing system. There are also some detailed questions here. It could also be interviewer actually want us to design a parking lot to mimic what is the real world looks like, kind of the simulation game here. So basically, the interviewer wants us to have some of the car moving around in and out, and have some spot, and have some of the gate, have some of the attendant, some other stuff, like a video game that each of the player can play some car and also some other components are in the system to interact with each other. This is another one. Actually, if you're searching online or if you're searching the YouTube video, you will find a lot of the uh, similar explanation or interpretation about this design parking lot answers, and some of them focus on the type of the vehicles and the spot. I feel like those things are more fall into the category 2 here, the simulation game. Um, if you're following those kind of the things, it will be hard to see, oh, in the real world, how do we even know um, where the car is or something? So we need to make it clear this is something we want to solve and it's the correct one. This parking lot could also be something different, which is like in the uh, management office of the condo building or an apartment building. There will be some parking spots, and the administrator needs to be able to maintain the mapping or the relationship between the parking lot and the owner or the renter who rent or lease those lot. So this could be a parking spot management system. So inside this scenario, we expect the system would be able to allow the admin to edit the parking lot, delete or remove the parking lot, and assign an owner of the parking lot, and replace the owner, edit or modifying the parking lot. This will be also another different use case. We will have some assumption, but most important thing is that we need to talk with the interviewer and ensure that we are on the same page. We agree which is the one we want to go with in this interview. Because this is a tutorial, I do not have any interviewer to ask. I would like to go with the option 1, which is the one that are closest to the real world. And also interesting, I could not find so many videos talking about going from the option 1. So I would like to see how well I can explain it from this angle. So let's write this down. We will go with option 1. Now we are clear with the direction we want to go. We can talk about some more detailed questions here. So for the parking lot, the billing system, I think the billing system for the real world, we're normally dealing with the tickets. Um, when we're talking about the core object, Normally for the object-oriented design, and you will try to find some of the noun in the sentences. So for here, the parking lot. So parking lot will definitely be a core object here because we will do a lot of things for this one. And also, we need to deal with the tickets. No matter whether you pay it at the entrance or pay it at the exit, most likely you will get the ticket. If you pay at the entrance, basically you pay upfront, and you will have some amount of the time printed on the ticket, and quite often the system or the admin will ask you to put the ticket in front of your dash so that some other um, people check the car around. They will know whether this car um, has paid or not. If you pay it at the exit, basically it means that the system need to record that when they issue you this ticket or when you arrive at the parking lot, and will charge you accordingly when you exit. So we have some options here as well. Pay at entrance or at exit. We have both valid examples in the real world, and we also need to confirm with the interviewer which one we want to go with. Here, I would like to go with the option 2, pay at the exit. This is the more used one actually not more used. I do see both of them in the parking lot or the parking garage. But let's choose the option 2 here. So what's the other? I think the other part is that the billing. So we need to deal with the money, right? How we charge the customer fees, and we can charge customer uh, in the real world. We can charge the customer various ways: by cash, by card, or by some other ways. So we can define something for that part. Both of them are represent for the how do you pay this one. So let's call it the pay method. This one will later allow us to dealing with various things inside this one. And you may also wonder, for this system, we will also have some of the customer, and we will also have some kind of the vehicle. Should we model those? That's a good question. It depends on how we design the system, or it depends on the major use case there. So in the real world, you can imagine that in the parking lot, does the system or does the admin need to know who you are or who you are the vehicle? Actually, they do not care too much about that one. They mainly deal with the tickets. So basically, they issue you the ticket, and then they will charge against the tickets. It doesn't matter who you are. It doesn't matter whether you are driving a red car or a blue car, or for our use case, we do not need to care about the customer or the vehicle. So the similar question will be, do we need to care about the parking spots? And what's the difference with the parking spots with multiple levels and multiple entrance and exit? That's also a good question. It depends on how we want to deal with the issue. As I mentioned, if we're only dealing with the billing, those things, all of the things are not related to this one. It might be necessary or required when we need to support some other use case, like we want to provide a dashboard for the available spots or available count. Then for those things, we might need to introduce some additional data structure here. But for now, let's start with the minimum viable product to ensure that we can show the interviewer something. And then starting from here, if we still have time, we can discuss with the interviewer, or the interviewer might have some kind of the follow-up question to challenge you how you can refactor your system to support the more use case here. So for now, we can just ignore this one as well. So we kind of have those core objects here. Then let's look at the use case. So if we go on a little bit, this is the use case. I think my whiteboard is not large enough to write all of the things here. Yeah, so the use case. Imagine in the parking lot, we can have different angle to look at this problem. Okay, let's look at the use cases. So if we look at from the customer's angle, we will see that the customer will first drive the car and stop at the entrance, and then press the button, and then the parking lot will give you the ticket, and then the customer need to park the car on the left, and then so on and on. That is a valid one. But then we are dealing with the customer. I think it's simpler that we're looking from another perspective, from the parking lot one. It's basically that the parking lot has a system that will always serve the customer. So when new customer arrive, they push the button, the system will receive the request, and that will issue you the ticket. Let's write down something. So the first thing is the issue ticket. Basically, this is where the starting point the system interact with the customer or the client side. And then after that, the parking lot does not do any additional things. The customer will find available parking spots and park it. Sometimes you will also see on the online video, there will be some design around how the system find the available parking spot using some fancy algorithm close to the elevator or close to the entrance and assign to the customer. You can do it on the design, but it's better to check with the interviewer. My feeling is that in the real world, I rarely see any parking lot that assign the parking spot. Sometimes it's quite easier for the customer to find the available one, whatever they can see in front of them, instead of assign a spot, because finding those spots can be more challenging than expected in the parking spot. Sometimes you have no idea where the spot is, why we need to assign that spot, right? Then another major thing for this system is that the next time when the client dealing with the system is when they check out or when they exit or want to pay the money. And we have already designed that we want the customer to pay at the exit. We can directly charge the customer the fee, but for the real world experience, normally you will insert the ticket and the system will show you the money that you will pay. So the second use case is the preview fee. Customer need to know that how much money I would like to pay before I paid without any surprise. And then after customer see the price, the third one is to really pay the money, or from the system's perspective, we is charging fees from the customer. So this is charge fee. And after we have done all of those things, customer should be ready to go. And we are happy we get the money. So from the system's perspective, the billing system, as long as we support those three use cases, we should be good enough to go. We can also check with the interviewer to ensure that we are on the same page. And this use case we can write down in the whiteboard, use it as a reference. This can be kind of the contract between interviewer and interviewee, so that we know that our target is to tackle those problems in the next half an hour or 30 minutes. So we have the same understanding what is the scope, what we would like to solve here. Now we are clear with the use case. Let's move on to the classes. I run out of the space for this one. I will move on the whiteboard a little bit. So the classes is here. Let me still draw a line here. Okay. So the classes, what we can do for the classes. For the classes, let's also start with the parking lot. We can use some kind of the UML class diagram. It has some those kind of the format here. There's a rectangle. On top of it is the name, and then you will have some attribute. It will have some simple in front of it, which means the private, public, or default, the package level 1. So those are something mapping to the Java accessor. After that, it will have some function. This can help us to quickly identify the kind of a little bit deeper details for those class. And the reason we choose the class diagram over coding is that it's easy and saving some time, and also can help you to avoid those kind of the challenging or the details that you need to dealing with or struggling with when we do the coding. So it's better that we start with the class diagram. And it's always, if we still have time or the interviewer insist on we do the coding, we can easily convert those class diagram later into the real coding part. Okay, let's get started. So class diagram. Let's start with parking lot. So we will have a parking lot class. And this parking lot, I think the parking lot for this stuff, we mainly deal with the ticket. So we will have a list of the ticket here. And this thing is something we will market as private, so only the system will be able to handle it. And the external client will not be able to see or manipulate this one. Then we will see what is the function that we require to support here. The first thing is that there will be a public function called the IssueTicket. The IssueTicket, actually, we do not need to take into any input. If you recall what's in the real world, we just press a button. System does not ask us anything. And the output is that it will return you a ticket. We will later define what's inside in this ticket. The next one, as the use case mentioned, that we have something, let's check it again, preview fee and charge fee. So the next is the preview fee. And for this function, if you recall in the real world, we will insert the ticket into the machine. So basically the system requires some input from our side. So let's put the ticket here. And the output is normally, it will show some information on the screen, like you need to pay $10 for this parking. So for simplicity, we can return a double here to show what is the required number. The last one is the charge fee. So then customer need to pay this money. Normally you will insert or tap your card into this one, but we need to keep in mind that for the system, we want to make it flexible for the potential future use case, which means that we may want to support the cash or support some other ways in the future. So here we put the pay method. And also, most likely when you do this thing, the ticket is still in the system. And it is something that we need to do something for the ticket, either for the tracking and recording purpose or for the customer for some other like the invoice or for the reimbursement purpose. And the charge fee, normally we do not need to return anything, we just charge it. So it's a void. And this is a happy case. If we want to see how we deal with some unhappy case or the abnormal case, we will later discuss it, how we use it. Either change the output or using some exception. Then let's look at another one. We have already talked about the ticket. What will the ticket look like? We have another class called the ticket. The ticket will have an attribute. The most important thing is that the system need to know when you arrive or when the ticket has been generated or issued. So we will have a attribute called the IssueTicket. And the data structure type will be the date time. We need to know when this was being created. And also for each of the ticket, they will have the ID or most likely a one-dimensional or two-dimensional barcode printed on the ticket. We call it an ID here. It will be used for tracking and identification purpose. If you are familiar with the database or something, or when we design the schema or something, most of the entity will have ID, which will later be used as the primary key in the database. That's pretty much it. And the ticket, we do not need to have some of the method or functions inside this one. And then I think the last major thing is the payment. So let's give some more room here. what will the payment look like. Pay method. So the pay method, you can see it's something that we require to input it here. And the pay method, we have multiple ways to deal with it because we know that the pay method is some kind of the generic one. And most likely we will have some derived or some class inherited from this one, like the card or the cash or something. And we need to know what's those kind of the common things here. If we define some of the attributes, most likely this pay method will be a kind of the abstract class. It's kind of okay, but I think the better way is that we define it like the interface, so that we want to know that for the pay method, what is the common way that we need to deal with. I think the pay method, most of the things we want to pay method be able to support the behavior like the pay, and want to we want to pay the amount of the money, which is double. And different ways will have different implementation details here. Then I think the pay method we will have something that be able to uh, support this one. So we will have the card. We will also have the cash. And it might be in the future we have some other fancy ways like the online payment method, PayPal, or you might also be able to see in some place they might be support like the Bitcoin or some other fancy stuff, really fancy. And for the traditional one, the CAD, the card might also have different things like credit card and the debit card might have different paying channel. So and also you will notice that in the supermarket, sometimes when you before you pay the money, the associate will ask you whether you want to pay with the credit or the debit. So system definitely need to deal with it. And sometimes they will also ask you what kind of the credit card. Are you using the Visa or are you using the MasterCard? So those kind of the hierarchical stuff here. And then this is all of things. As long as those things are able to support the pay from the system perspective, it makes no difference with us. We just call them and give the ticket. The ticket will later do what is the required the thing we want to charge them. And I think we covered most of it. And then the last thing, let's look at the last step. What is the last step here? Is the correctness. So let's look at, we have checked with the interviewer, the issue ticket, we support this one. The preview fee, we support this one. The charge fee, we support this one. So we should be able to cover all of the things. And the interviewer, if we still have time, interviewer might ask you some follow-up questions to challenge you to see whether you can get some bonus points or whether you really understand those stuff or how you handle the use case being changed. For example, in this one, they might ask you to see whether you can put some more details about the preview fee part. So how do we be able to support the preview fee? Maybe let's use the left minutes here to see how we can support this one. So the preview fee will ask you for the ticket, and you will have some implementation details. You can do whatever you want and to return something here. But is it possible that we can make it more flexible ways to deal with it? I think here we can try to use some kind of the design pattern like the strategy pattern. We can define a interface like called the fee calculator, because we know for sure that these things might be changed frequently. Maybe when the system starts at the very beginning, we have the simple way. So the fee calculator will have a double as the return. We want to calculate the fee and the estimate. And for those things, we can do a lot of the stuff. We can directly put the ticket here, but it will pass you too many information. Actually, what we want is just the two things. One is the date time, the start, and the other is the date time end. As long as we have those start and end, we should be able to support it with different things. And inside this one, we might have different detailed implementation class. Like normally you will see something called the flat rate. Flat rate, it's basically just we'll implement this one. It's just how many hours or how many, most likely how many hours plus this one. And also you can kind of have those more advanced one like the tiered rate fee calculator. What this will do different is that it will like the first 30 minutes will charge you the higher one, and the next 30 minutes a lower one, and the next 1 hour even lower one. And also you might come up with some kind of the complex one, like it will also include that for the weekday we will have the higher one or lower one, depends on whether it's the business building or the shopping mall, and what will be different for the holiday and for the weekend. So those kind of the things we can define here, so that later it can easily be changed with the minimum change of the code here to support this use case. And I think that's pretty much for this one. If you would like to learn more about it, please leave your comments here, and we will see you next time. Bye.